Hello everyone. Hello everyone. The objective of this video is to learn how to count the number of significant figures using the significant figure rules. So this is basically using the significant figure rules to find the number of significant figures in a given number. In the previous video, I have discussed about the rules regarding the significant figures. So please go back into that video and try to understand the deeper concept about significant figures. In this video, I'm going to show you how to count the correct number of significant figures in a given number. The first rule, or more like the guideline, is non-zero digit. When you are given a number, check what type of number you have. Check if you have any zeros. Check all these numbers. Are there any zeros? You don't see any zeros. So in the first significant figure rule, we say that all non-zero digits are they are always significant. So let's count the number of significant figures in each of these given numbers. The first one, you don't see any zeros. Let's count the numbers. 1, 2, 3, 4. So you have 4 sigfigs. Second one, start counting. Do you see any zeros? No. 1, 2, 3, 4, 5. 5 sigfigs. You have a measurement 32 inches. You don't have any zeros. 1, 2. This one has 2 sigfigs. 3.42 liters. Start counting the number of significant figures. You don't see any zeros. 1, 2, 3. You have 3 sigfigs. This number 2.74 grams. 1, 2, 3 sigfigs. Things become a little bit complicated when we have zeros. So there are several rules or guidelines that govern how we calculate the total number of significant figures when we have zeros. The captive zeros are the zeros that you find trapped in between two non-zero digits. So all captive zeros, they're always significant. So check these numbers. The first number, you have 2 zeros, they're trapped in between two non-zero digits. So let's start counting the number of sigfigs. 1, 2, 3, 4. This number has 4 sigfigs. Second number, this zero is a captive zero, it's trapped between two non-zero digits, and so is this zero. So let's count the number. 1, 2, 3, 4, 5. You have 5 significant figures. Next number. This is the only captive zero. 1, 2, 3, 4, 5, 6. You have 6 sigfigs. The next number. These two are captive zeros. These two are captive zeros. They are all significant. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8. Alright. The next type of zero is the leading zeros. Leading zeros, these are the place holding zeros. They are never significant. So keep in mind, it is never significant. Usually when you have leading zeros, you might notice this decimal point. So these zeros are all leading zeros. So I'm going to draw an arrow like this in this direction until I hit the first non-zero digit. And then I start counting the remaining digits. 1, 2, 3. So I have 3 sig bits in this number. I have another number, 0.57. This is a leading zero. Leading zeros are not significant. So this has 1, 2, only 2 significant figures. Next number. All these zeros in front of number 8 are not significant. Number 8 is the first non-zero digit you see. So I'm going to draw an arrow like this until I meet the first non-zero digit, and then I'm going to count the remaining digits. 1, 2, 3, 4, 5. 5, 6 bits. Next up, I'm going to go through all the leading zeros and I found the significant figures. Now this is 2 significant figures. Now the most confusing part for many students is these trailing zeros. Now trailing zeros can be visualized in two different ways, with the decimal point and without decimal point. Now this decimal point, whether you see it or not, that makes a big difference. So if you're seeing trailing zeros with no decimal point, those zeros are never significant. So I'm talking about the decimal point. Let's look at this number. Do you see a decimal point? No decimal point. So when you don't see a decimal point, you usually draw an arrow in this direction. So I'm going to draw the arrow from right to left until I find the first the non-zero digit or real number. So I'm going to go through all these numbers. I have a 0. This keeps happening until I hit the first real number. I'm going to draw this arrow from right to left. And how many significant figures? This is the only real number. So this number has only one sig bit. The next number. Excuse me. The next number. Do you see a decimal point? No. So you can start drawing the arrow from right to left. So I'm going to start drawing it like this until I hit the first real number. Alright, now I'm going to count the total remaining digits. 1, 2, 3, 4. So this number has only 4 sig bits. Next number. Do you see a decimal point? No. So you can go from right to left, cross through all the zeros until you find the non-zero digit. How many sig bits? 2. Next example. Do you see a decimal point? No. So you can draw the arrow like this, count the number of remaining digits. 1, 2, 3. This is 3 significant figures. The next type of trailing zeros are the ones where you see the decimal points. So when you see the decimal point, they are always significant. And when you see the decimal, you start drawing the arrow from left to right. Alright. The first number you see. Do you see a decimal point? Yes. You have your decimal point over here. So you're going to start drawing the arrow from left to right until you find the first non-zero digit. Did you find it? Yes. 6 is your first non-zero digit. Starting from this point, start counting how many digits are remaining. 1, 2, 3, 4, 5, 6, 7. Now this number is holding 7 significant figures. Let's check this number. Do you see a decimal point? Yes, your decimal point is over here. When you see the decimal point, draw the arrow from left to right until you find the first real number. Now you hit the real number 5. Start counting. Now once you start counting, you don't stop. No matter whether you are going to see more zeros or not, you just don't stop. You start counting and continue counting. 1, 2, 3, 4, 5, 6. You have 6 sig figs. Next number. Do you see a decimal point? Yes. So draw the arrow in this direction until you find the first non-zero digit. Start counting. 1, 2, 3, 4, 5, 6, 7. 7 sig figs. Next number. Do you see a decimal point? Yes, you see it over here. Draw the arrow until you find the first non-zero digit. This is your first non-zero digit. Start counting and don't stop until you complete. 1, 2, 3, 4. 4 sig figs. Next number. Do you see a decimal point? Yes, you have one over here. Draw the arrow until you hit the first non-zero digit and then start counting. 1, 2, 3, 4, 5, 6. 6 significant figures. The next number. You see the decimal point. Draw the arrow until you find the first non-zero digit and then start counting. 1, 2, 3. You have 3 sig figs. Now I have mentioned exact numbers as a guideline here. This is a very rarely spoken topic. Exact numbers, I have explained this in a previous video. Exact numbers hold an infinite number of sig figs. It's going to have an infinite number of sig figs. So when you are reading any numbers, pay attention what you're reading. Read very carefully and pay attention to the units or whatever the information that is given. So what is an exact number and inexact number? I have explained that in a previous video. When you read the information, see if you are counting or measuring. If you are making a measurement, if you are measuring something, that means you are dealing with inexact numbers. If you are measuring, that means you are working with inexact numbers. If you are counting or using conversion factors or using definitions, simple fractions, those fall as exact numbers, and exact numbers have an infinite number of sig figs. Let's look at the first one. 10 apples. Did you count or measure? You're counting. So this one has an infinite number of sig figs. So this one you count. How about 5 pencils? You're still counting. So you're going to have infinite number of sig figs. 100 students. You still count. Infinite number. What about this one? Now this one, actually this is 5. Given as this, 5. This is a fraction. Fractions are considered as exact numbers. Now don't confuse fractions with decimals. Fractions and decimals are two different things. Fractions are exact. Decimals are probably not. Most often they are not. This number. This is a fraction. This is again a fraction. Fraction is an exact number, so this is going to have an infinite number of sig figs. Molar mass. Now this is a definition. Definitions count as exact numbers. You can see grams per mole. Now this is not just grams or not just moles, this is a unit, and by looking at the unit you can figure out if you're working with a conversion factor or a definition or a fraction. So this is a definition. Definition fall as exact numbers. Number of atoms, basically counting the number of atoms, and also this is a definition of mole, and because of that this is also an exact number. 1 meter is 100 centimeter. What is this? This is a conversion factor. This is a conversion factor. So conversion factors are also exact numbers. So all these numbers listed here, they all have an infinite number of sig fig. How do you know? You have to decide whether you are measuring or counting or converting. So you have to read very carefully and think what you are dealing with. Are you dealing with a measurement or an exact number? All right. Let's practice some problems. Now all these numbers listed here contain only one sig fig. How do you find the only remaining single significant figure? Do you see a decimal? No, you don't see a decimal. So draw the arrow until you hit the non-zero digit. Only one sig fig. Draw the arrow. Do you see any zeros? No, this is just standing alone. So this is quite easy. Second, next one. This is also quite easy. You don't see any zeros at all. Just one sig fig. You see a zero, but you don't see any decimals. So you can draw the arrow like that. And then how about these? These are all leading zeros, and you see the decimal. See, you have the decimal here. Once you see the decimal, you can draw the arrow in the other direction until you find the first non-zero digit. You have the decimal point. When you see the decimal point, you have to decide which direction you should be drawing your arrow. Alright, let's do some practice. What is this? Is this a measurement? Yes, it is a measurement. You see the units in meters. Do you see a decimal point? No. Draw the arrow until you hit a real number. This is where I stop. 1, 2. I have 2 sig figs. What do you have? Do you have a measurement or counted number? You have seconds. We measure it. Do you see a decimal? Yes. So start drawing the arrow like this until you hit the first non-zero. Start counting the numbers. 1, 2, 3, 4. Once you start counting, you keep counting all the zeros that is not crossed. So now you have 4 sig figs. 10 bananas. Are you counting or measuring? You're counting. So actually this information, this contain an infinite number of sig figs. 10 meters. Are you counting or measuring? You are measuring the length. Do you see a decimal or not? There is no decimal point. So draw the arrow this direction until you hit the non-zero digit. You have only one sig fig. Are you counting or measuring? You are measuring. Do you see a decimal? Yes. Draw the arrow. Start counting the remaining numbers. 1, 2, 3, 4, 5. 5 sig figs. Are you measuring or counting? You have a type of unit. You are measuring. Do you see a decimal? Yes. And then From left to right, draw the arrow until you hit the first non-zero digit. Start counting the numbers. 1, 1, 2, 3. You have 3 6. Are you measuring or counting? You are measuring. Do you see a decimal or not? You don't see a decimal. So when you don't see a decimal, you can go this direction. How many sig figs you have? 2 sig figs. Alright, let's practice on deciding which way you are going to draw your arrow. When you see the decimal, you draw it from left to right, and when you don't see the decimal point, see in all these numbers, you don't see the decimal. So you draw the arrow from right to left. When you see the decimal, you draw the arrow until you hit the first non-zero digit. So arrow goes through the zeros and you have to stop at the real number and then start counting the remaining numbers, and the remaining numbers mean including the zeros that were not crossed.